Okay, hello guys. Today is our third lesson in the IGCSE, maybe for sixth chapter. Okay, we are just learning for numbers and also for ratios. Okay, so we're just talking about for direct and inverse proportion. Okay, let's move into the first part about what is for direct proportion. Okay, so here's an example for you. Like here, we are using the symbol to represent for the direct proportion. Okay, so maybe here you can find here is for the formula y equals to kx. Okay. So maybe I guess you're not very familiar with like the like for this formula, okay? Because I guess for many of the times you're not very familiar with y-axis, okay? But maybe I'll give you an example in our daily life, which can help you to understanding better about directly proportional, okay? So maybe for consider like the same if you're just preparing for your test, okay, preparing for your final, okay? And you take a lot of times on your homework, take a lot of times for reviewing, and you'll find that, oh, maybe you're just learning very hard for maybe for 2 hours for a day, right? Maybe 2 hours a day, and you'll find, oh, finally, I got a very good score, maybe for A star, or maybe if you're in the European, you get for a nine grade, nine grade, you are very good in your test, okay? So maybe if you're just learning for 1 hours a day, maybe in the final, you cannot finishing or all reviewing for all the knowledges. So maybe finally you'll get maybe for an A or maybe 8 of 9 scores in your final. Okay. So maybe it becomes a pity. Oh, maybe if you're less of time, if you're just addicting in the TikTok or just addicting in YouTube, okay, so maybe you take 0.5 hours a day and you'll find that, oh, maybe you finally you'll get a B score on your test, or you get a 7 of 9 scores. Okay, that is maybe for Asian. I mean, we'll also have a joke that for Asian people, so for Asian students, they also have the mom that always saying that you're an Asian, not a Bayesian, right? Okay, so here we can just understand it for here, maybe for your like preparing for more times before the test, you're have a greater tendency to get a higher score, right? Okay, so we can just consider like the time taken before the test and the final score you get or you achieve, that they have a relationship. Maybe for the time increase, for the scores you're also increase. Okay. So maybe here we can just consider like here, maybe we have y equals to 2x, the k is a constant. Okay, so we can just consider k as 2. So if we have x equals to 1, so y equals to 2, x equals to 2, y equals to 4, x equals to 3, y equals to 6, right? So you can find when x increase, y also increase, right? It's just like the example we thought, like you have a lot of times to preparing for your test, or more times to preparing for your test, and you'll get a higher score in your final, right? Okay, so we can say that it's called the direct proportion, okay? So another relationship is called inverse proportion. Okay, so here we can find the formula is y equals to k over x. So maybe if just have some like relationship that they have different or opposite relations, right? Like maybe if you're lazy, okay, you waste of the time before your test, okay? So if you waste 1 hour a day before a test, or maybe you'll get an A score in your final, okay? If you waste 2 hours a day and you're said, oh, maybe here you finally get a B score in your test, or maybe you're waste for 3 hours a day and you get a C score. Okay, so consider as this way, and you can find maybe the more time taken you have before you're just taking your final, and the more wasting time means that you have maybe your tendency is to just get a lower score, right? So we can find that maybe here the number is increased, but for here the scores is decreased, right? So we can consider like here, maybe we can just consider as k equals to 2, so that is y equals to 2 over x, right? So if x equals to 1, y equals to 2, x equals to 2, y equals to 1, x equals to 4, y equals to a half, right? And you can find when x increase and y decrease, right? So we can say that this means x increase, y decrease, or x decrease, y increase, okay? They have a very opposite relationship, okay? When somebody is increased, another part must be decreasing, okay? So here is also for some other proportion with powers, okay? So maybe I'm not sure that if you're very familiar with powers, but so here just an extension, okay? So if you already learned about powers, you can just write it down here, like x squared, we knew that it's for x times x, right? So if y is directly proportional to x squared, we can just write it as y equals to kx squared. If we have y directly proportional to the x squared root, and maybe here we can say y equals to kx squared root, okay? And also for inverse, you can, for making an inverse square, like here, y is inversely proportional to the y over x squared, and you can write it as y equals to k over x squared, okay? That is for the proportion and the powers, okay? So I guess maybe for here, just to understand why is that and how you can build the relationship between the other, okay? So here is some working examples for you, okay? Like here for the question is that, oh, maybe for here, y is directly proportional to the square root of x, right? And when x equals to 3, y equals to 18, and find y when x equals to 5, right? So here you can find is that y is directly proportional to the square root of x, right? So maybe here, just trace back to here, we said y is proportional to the like x squared. So you can set maybe here is y equals to kx squared, right? You can just write down it this way. And maybe for here, when x equals to 3, y equals to 18, you can just let x's value and y's value into the equation, right? So it becomes 18 equals to k times 3 squared, right? So finally here, k equals to 2, okay? And we have k equals to 2, so that means we have y equals to 2x squared, okay? And then it said find y when x equals to 5, right? So we can say, oh, if x equals to 5, we can just put the x value into this formula that becomes y equals to 2 times 5 squared, it equals to 50, okay? That is for y's value, okay? So that is for here, I guess you can just understanding for how to calculate the x and how to calculate y, okay? Another example for here is that y is inversely proportional to x, and we knew that the formula is y equals to k over x, right? We just have an example before, like y equals to 2 over x, right? So it said when x equals to 4, y equals to 10, find x when y equals to 2. So when x equals to 4, you can set here, maybe we can write it as 10 equals to k over 4, right? So k over 4 equals to 10, so you can just consider it like here, the answer is k equals to 40, right? Okay, so k equals to 40. So y equals to 40 over x, and it said find x when y equals to 2. So here when y equals 2, you can say x equals to 20, right? So here the answer or the value for x is 20, okay? That is for this example right here, okay? And here's also some deliberate practice for you, okay? So you can just pause the video if you have the time and you want to just try out yourself at the first time. So please pause the video and trying to think on yourself. So if you want to just follow with me and to solve all the questions, you can just keep on going, okay? Okay, so for the first question is that y is directly proportional to x, and when x equals to 5, y equals to 30, and find y when x equals to 12, right? So we knew that for here, y is directly proportional to x, so we have y equals to kx, right? And when x equals to 5, y equals to 30, we can just put the value into this, say 30 equals to 5k, right? And we knew that k equals to 6, okay? So we have y equals k equals to 6, and we can set, oh, here is for y equals to 6, that's right. And the answer, oh, sorry. The question here is find y when x equals to 12, okay? So y equals to x equals 12, that is 6 times 12, right? That is for here. The answer for here is for 72, okay? That is for this calculations. Okay, so for here, y equals to 72, we can set like 6 times 12 equals to 72. Okay, so for the second question is that like P is inversely proportional to Q when Q equals to 10, P equals to 2, and find a P when Q equals to 4, right? So you can set here, maybe P inversely proportional to Q, you can write down as P equals to K over Q, right? And then you can put the values into it, and Q is 10, P is 2, 2 equals to K over 10, so K's value is 20, okay? So here you can set P equals to 20 over Q. And if you want to find the P's value, you can just put Q's value, Q equals to 4, right, into the equation, right? So P equals to 20 over 4 equals to 5, okay? That is for the second question, okay? And for the third question is that y varies directly as the square root of y, right? And so you can set y just proportional to the square root x, right? So you can just write that as y equals to k times square root x. And when x equals to 16, y equals to 10, you can set, maybe you can put the value into this, right? Like 10 equals to k times square root 16. And here, k's value equals to 5 over 2, okay? So you can set, for here, the equation is y equals to 5 over 2 square x, okay? So if you're not very familiar with this, don't worry about it because this is just for the parts in algebra. So I guess for number theory, you don't need to understand for so much. If you're just understanding for the first question and second question, it's enough, okay? And for the first question, it said f is inversely proportional to the square of the d, okay? So we can say that is f equals to k over x squared, right? And it said, oh, sorry, d squared. If d doubled, what happens to f, right? So d doubled and the value becomes k over, maybe here for is k over 2d squared, right? And becomes k over 4d squared. So here you can find f's value from f just turned into f over 4, right? So we can say that the final answer of f or final value for f just divided by 4, okay? That is for the total answers right here, okay? I hope you can just take a note and just to understand for all the problems, okay? Okay, that's it for today's our total lesson. I hope you can just understand of them and hoping you can doing some more exercise after you're learning for direct and inversely proportional questions, okay? So that's for today's our lesson. See you next time. Bye.